Hello again, everyone. In our last topics, we already discussed the series, circuit, parallel circuit, voltage, and current divider theorems. Now, we'll go to the combination of series parallel circuit. So, components are connected in some parts and parallel in others. We won't be able to apply a single set of rules to every part of the circuit. Instead, we will have to identify which parts of that circuit are series and which parts are parallel. Then selectively apply series and parallel rules as necessary to determine what is happening. So take the following circuit for instance. In this circuit, we can see that R1 and R2 are simply in parallel. R3 and R4 are in parallel. So if we take the parallel combination of R1 and R2, we will have a circuit, or we will have a resistance of R12 will be equal to R1 in parallel with R2, same in R3 and R4. We will have a resistance of R34. So R3 in parallel with R4. Then we can redraw this circuit by the equivalent. So this one is your source. This first resistor is the combination of R1 and R2. So we'll have R12 and R34. Now we can further simplify this circuit. As you can see, R12 and R34 are in series. So the equivalent circuit now of this series combination is looks like this. We will now have your total resistance. So solving now for total resistance, it is the sum of R12 plus R34 because they are in series. So this is now your simple Ohm's law. This is your terminal voltage or source voltage, your total resistance now, and your total current. We will try to solve the total resistance of this kind of series parallel combination. So we have the parallel combination of R1 and R2. R12 is equal to 100. Let's say R1, from our formula, R1, R2 divided by R1 plus R2. So R1 is 100 multiplied by 250 divided by 100 plus 250. So you will get 71.429 ohms. Next is your R34. So 300 R3 R4 divided by R3 plus R4. So 350 times 200 divided by 350 plus 200. So that is equal to 127. So R34 is equal to 127.273 ohms. Now, the series combination of R12 and R34. So, we have now your R total is equal to R1234, R12 plus R34. So 71.429 plus 127.273. 198.702 ohms. So this is your total resistance. So the equivalent circuit of this combination is this one. So this is now your 24-volt source and 198.702 ohms as your total resistance. So from here, Ohm's law, you can now solve your total current. So in this figure, the direction of your currents here will be, this is your total current, and it will divide into two branches. So branch 1, which is your R1, and branch 2 is your R2. So let's say the current flowing in R1 is I1, current flowing in I2 is I2. And again, this I1 and I2, they will meet again at this node. And current flowing here will be equal to your total current again. Then total current, it will split again into two branches. Current flowing in R3 is your I3. Current flowing in R4 is I4. Again, I3 and R4 will meet at this node, and the total current again here. It will go back to the source. So this is your total current. So that is the flow of your currents. So solving for I1 here, you can use the current divider theorem. Also, all of the branch currents, you can use the current divider theorem. So that is the application of the current divider theorem. Later on, we will solve the branch circuit currents and the voltage drops, but we will try to solve more total resistances in different kinds of series parallel combination. Let's try to solve this first problem. So solve the total resistance, branch currents, and voltage drops of the following combinations. So later on, we will simulate this circuit in electronic workbench. for us to see if our calculations are correct. For now, we will try to solve the total resistance and the branch currents, also the voltage drops of this given combination of series and parallel resistors. First, we can see here that it is connected to a source equal to 12 volts. We have R1 9 ohm, R2 12, R3 6, and R4 5. We will label the circuit by its direction of current. So for our total current, we have here, we can see that our total current is equal to the current flowing in R1, which is I1. So this one is our total current, and it will divide into this node R2 to be downward direction, your I2, and your R3, which is I3, downward, this is I3. This combination or these branch currents will meet at this node. So it will go to our resistance R4, which is 5 ohms, and the current flowing here will be equal to your total current. So direction of IT again is equal to the current in R4, which is I4. So this one is total current. Therefore, we can say that your total current is equal to I1 equal to I4. Later on, we will be able to solve your total current. But before solving your total current, of course, you need to solve the total resistance, because from our Ohm's law, diba, total voltage is equal to total current multiplied by total resistance. So what will be the value of our total resistance? Examine your circuit that these R2 and R3 are connected in parallel, diba? And after the combination of R2 and R3, it will become one resistor, R23. And your R1, R23, and R4 will be connected in series. So let's try to solve first your R23. So R23 is equal to R2 in parallel with R3. So 12 multiplied by 6 divided by 12 plus 6. So that is equal to 4 ohms. Or redraw your circuit, it will become like this. So this is now your R1, this is your R23, and this is your R4 connected to your source voltage 12. So total resistance now is the sum of R1, R23, and R4. So total resistance is equal to R1 plus R23 plus R4. So R1 is 9 plus 4 plus 5. So that is equal to 18 ohms. The equivalent circuit now will be looks like this. Source, your 12, and your total resistance. Simple Ohm's law, you can solve your total current. So IT is equal to What is our source voltage? So 12 volts divided by 18. Total current will now be 0.667 ampere. So this one is our first answer. Total resistance, our total current. Now, how will we solve the current in R2 and R3? But first, so IT now is equal to I1 is equal to I4 equal to 0.667 amperes or ampere. So using CD, solving now the branch currents I2 and I3. So we will use the CDT, current divider theorem, which is IN equal to total current multiplied by total resistance divided by Rn. So this total resistance here is not the total resistance of the circuit. It is not the total resistance of the circuit. Instead, this is the combination of the two parallel resistors. It is the combination of the two parallel resistors. Nilip-lipatan dito. In this case, the two parallel resistors are the R23. Therefore, RT here will be your R23. So, let's say IN is equal to total current multiplied by R23 divided by your Rn. So, in this case, we will solve first your I2. So, I2, this is your IN. Okay. It is equal to our total current, which is equal to 0.667 multiplied by R23. So, we already computed R23, which is equal to 4 ohms. So, 4 ohms divided by the resistor in I2. So, that is your R2, which is equal to 12 ohms. So, divided by 12 ohms equal to I2 is 0.222 ampere. So, next is I3. We can solve I3 using two methods, the KCL, Kirchhoff's current law, and the CDT. First, we will try the KCL from your physics, Kirchhoff's current law. So, current entering into a node is equal to the sum of the current leaving into the node. In this case, we have a node here. So entering into the node positive is IT. It is equal to the sum of the current leaving from the node. So current leaving is I2 and 3 plus I3. So I3 is equal to IT minus I2. 0.667 minus 0.222. So that is equal to 0.445 amperes. So using CDT, we have I3 is equal to total current R23 divided by R3. So 0.667 times 4 divided by 6. So that is 0.445 ampere. So they are equal. This is I4. For the voltage drops in each branch or in each resistor, we have the formula again. V1 is equal to I1 R1. V2 is I2 R2. V3 is I3 R3. So these voltage drops can be measured using voltmeter. While currents can be measured, let's say IT, I1, I2, I3. So these currents can be measured using ammeters. So later on, we will simulate this one in electronic workbench. Now we are going to simulate our circuit a while ago in an electronic workbench. So this is the workspace of an electronics workbench. Here we have your sources, the batteries, the current source, voltage source, and so on. Here are the resistors, capacitors, inductors, transformers, diodes, full bridge, and electronics. Ito yung mga voltmeter, ammeter, lamp, bulb, and so on. So we will try to simulate our circuit a while ago. We need a voltage source, 12 volts. So, eto. And resistors. 4 resistors. So, 1, 2, 4. Right click, rotate, and right click, rotate. To measure the currents flowing in this resistors, we will use ammeters. So here, this part is the positive terminal of your ammeter, and this part is the negative. So as you can see, the positive terminal line is much bolder, and connecting ammeter into a circuit is, you must consider the polarity, because if you will napag sinukat mo DJ terminals na the positive and negative, it will end up reading negative current. So as you can see here, our source is, this is the negative positive. The flow of current is from negative to positive, so we must consider the polarity of an ammeter. So here, since this is negative positive, the next one will be negative and then positive. Okay? Para maging positive yung reading ng ammeter. So another one, this is positive, negative, negative, positive, negative, positive, negative dapat dito, and then positive. So we will rotate. Yan. Ito pag yanan na. Okay. The ammeter for this resistor, negative, positive, negative, positive. So dapat negative yung nasa taas. Etong part na to. So that is positive. Okay. Negative, positive. In series, para ma-read yung current. So another one, ammeter. So since they are in parallel, negative din dapat dito, and then positive. Yan. We'll now connect. For the voltmeter, it is across the resistor. We have here, rotate. So dapat positive dito. So let's see na lang. That is across 9 ohm. Dito din. Dito muna. The current reading here must be 0.667. This is your total current. And also here 0.667. At 12 ohm, we will get 0.222 or 2.22 milliampere. Here is 6.67 milliampere. dito 0.445. Okay? So, run. Yun. So, tama yung polarities. So, as you can see here, naging negative yung voltmeter. It means, let's try to rotate. So, negative pa din. Yun. Baguhin natin yung polarity nun. This is positive. Baliktad. Okay. So, eto yung voltage across 12 ohm and 6 ohm. Yan. So, the voltage drop across 12 ohm is 2.666 volts. At 6 ohm is 2.666. Why? They are equal because they are in parallel. Etong 12 and 6. So, here at 9 ohm, you have approximately 6 volts. And in 5 ohm is 3.333 volts. So, tama yung calculation mo. So, we have here, second example. Solve total resistance, branch currents, and power dissipated in R3 and R4, also the total power. Given our circuit here, R1, 3 ohms, R2, 6 ohms, R3, 12 ohms, R4, 6 ohms, R5, 5 ohms, and we have a source voltage here which is 20 volts. So we will label the direction of currents of this circuit. So our total current is here. It is equal to the current flowing in R1 and R2. So total current here. So since R1 and R2 are in series, so same current flowing in this branch, and then your total current will divide it into these two branches which are R3 and R4. So current flowing in R3 is I3 and this one is I4. Then they will meet at this node, entering in this node I3 and I4, and the current leaving here will be your total current. So, direction of current here from negative to positive. So, therefore, total current is equal to I1 equal to I2 and equal to I5 because they are in series. And then solving now your total resistance. So from our circuit we can see here that first the R3 and R4 are in parallel. So let's say the combination of R3 and R4 is R34. So R3 is in parallel with R4. And then this R34 will have a single resistor. And you can see that R1, R2, R34, and R5 are connected in series. So, total resistance is equal to R1 plus R2 plus R34 plus R5. First, we will solve the value of R34. So, R34 is equal to 12 multiplied by 6 divided by 12 plus 6. So, R34 is equal to 4 ohms. Solving now your total resistance, we have 3 plus 6 plus 4 plus 5. So, total resistance is 9, 14, 28. 18 pala, 18. So, we have 18 ohms. 9, 14 plus 4, 18. And then, your equivalent resistance or equivalent circuit will look like this. So, this is now your total resistance, and then the current voltage source is 20 volts. So, total current is equal to 20 divided by 18. So, that is equal to 1.111 amperes. So, this is, nasolve mo na I1 is equal to, I2 is equal to I5. Alo tinasolve mo nga branch currents yan. Tilang problema mo ni I3 and I4. So, you can solve I3 and I4 using CDT. So, using CDT, you can solve I3 is equal to total current multiplied by the parallel combination of R34 divided by R3. So, 1.111 multiplied by 4. So, R34 is 4. And R3 is 12 divided by 12. So that is equal to 0.370 amperes. Therefore, you can solve I4 using KCL or CDT na lang. So, I4 is equal to IT R34 divided by R4. 1.111 times 4 divided by 6 amperes. So that is 0.741 amperes. So if you add I3 and I4, it is actually equal to IT because you can see here at this node, ito Urayjay. So current entering is equal to current leaving. So IT is equal to 0.370 plus 0.741. So that is equal to 1.111 amperes. Okay, so we already solved I1 to I5. Next is the power at R3 and R5. So solving for power again, in the case of R3, we have P3. So I3 squared R3 or the voltage drop at resistor 3 multiplied by I3. So, ito na lang kasi given na lahat. Hindi mo na kukunin yung voltage drop. So, I3 is 0.370 squared multiplied by R3 which is 12. So, 0.370 squared times 12. That is 1.643 watts. For P5, it is equal to I5 squared R5. So, I5 is equal to total current which is 1.111 squared times R5 is 5 ohms. So, P5 is 6.172 watts. So, last is your total power. So, total power is just also the product of total current, total resistance, or total voltage times total current. So, total current is 1.111 squared times total resistance is 18 ohms. So, 1.111 squared times 18 is 22.218 watts. So, i-try nga natin to VTIT. So, VTIT is equal to 20 multiplied by 1.111. So, equal to 22.22 watts. So, small discrepancy lang. Okay? So, you can try this one. You can simulate this one in electronic workbench. pagpraktisan nyo. Dapat kaswiti maala yung values. Of course, you cannot measure the power in electronic workbench electronic, but you can use the voltmeter, and then you just multiply the reading in the voltmeter corresponding to your resistance and then the current. Okay? Pagpraktisan nyo. Another example. So, two resistors, RA 7,500 ohms and RB is 15,000 ohms, are connected in series. So, if a 120 volt source is applied to the combination, letter A, determine EA, which is the voltage drop across resistor A, and EB, resistor B, when a 15,000 ohm resistance in the form of voltmeter is first connected across resistor A and then B. So, letter B, determine EA and EB if one 15,000 ohm resistance in the form of voltmeter is connected across A at the same time that another 15,000 ohm resistance is connected across B. We will consider first our letter A. So, we have two resistors connected in series. This is for letter A. And we will let this one as RA and RB. Connected to a source which is 120 volts. The condition at letter A is when a 15,000 ohm resistance in the form of voltmeter is first connected across resistor A. So, we have a voltmeter here. Across resistor A in the form of a resistor. So, let's say this is VA or EA. So, laiso. And in the form of a resistor. So, it has a resistance, let's say, RVA, voltmeter A is equal to 15,000 ohms. So, what will be the reading of your voltmeter? Since RA and this RVA, as you can see, are in parallel, before we can solve the voltage drop across this RA, we must first solve the current, and then we will use voltage divider theorem to solve VA. So we have a current here, which is your total current, and then we must first solve the total resistance of this circuit. So for here, the total resistance is equal to the parallel combination of RA in parallel with RVA plus, of course, after we combine these two, as you can see, it is in series with RB. So it is equal to RA is 7,500 multiplied by RVA, which is 15,000, divided by 7,500 plus 15,000 plus the value of RB is 15,000. So total resistance is equal to 20,000 ohms or 20 kilo ohm. Okay, we can simplify our circuit. So this is now your new equivalent circuit. This is your RA, VA, the combination of these two, and your RB. Now, after we solve the total resistance, we can now solve your total current pala muna. So, total current is equal to 120 divided by 20,000. So, total current is 6 milliampere or 6 times 10 raised to negative 3 amperes. After that, using voltage divider theorem, or simply the product of since this is series, diba, the current flowing in RAVA is the same current, total current. So, IT multiplied by RAVA. Or using voltage divider theorem is equal to total voltage multiplied by RAVA divided by total resistance. So, VAV is 6 times 10 raised to negative 3 multiplied by RAV, which is equal to the parallel combination. Yung diretso tayo namin itayin, detoy lang. So, that is equal to 5,000. So, equal to 30 volts. Let's try here. 120 times RAVA is 5,000 divided by total resistance is 20,000. So, that is equal to 30 volts. So, any of these two formula, padalata. Next, this is the first condition. First connected across resistor A and then across B. So, this is across A muna. Dito across A pa lang dito. Next one is across B. Yakar tayo ni voltmeter. So, again, we will redraw. Same procedure. So, this is 120. RA is RA 75. This is RA. RB is 15,000. And then you have a voltmeter here in terms of resistance. So, VB VBB. voltmeter V. So, ano ti reading ni voltmeter B? If you have a resistance which is 15,000. So, same procedure as you can see, RB and RVB are in parallel. So, RB in parallel with RVB is equal to, this is RVVB. 15,000 times 15,000 divided by 15K plus 15K. So, that is equal to 7,500 ohms. Next, after getting the value here, it is connected in series with RA. So, total resistance is equal to RA plus RBVB. So, 7,500 plus 7,500. We have 15,000 ohms. Okay? Next, busartela tati biditin. Hantal alante currenten. Voltage drop reading at voltmeter V is equal to total voltage times RB divided by total resistance. This is RVB. Ura mo pag sinukat yung data. So, 120 multiplied by RVB is 7,500 divided by total is 15,000. So, 120 60 volts. Letter A lang yan. So, we will go now to letter B. Letter B, what is the condition? Determine EA and EB if one 15,000 ohm resistance in the form of voltmeter is connected across A. At the same time, another 15,000 ohm resistance is connected across B. So, sabay na sila. We have two resistors, 7,500. This is your RA and RB. This is 15,000. This is our source. 120. And at the same time, may resistor tayo dito, which is 15,000. And at the same time, again, we have another 15,000 here. So, what will be the reading of your voltmeter EA and voltmeter EB? So, here, as you can see again, RA is in parallel with RB, diba? And this is RBA. RA in parallel with RVA and RB in parallel with RVB. And the combination of these two is in series. So, this will become RAVA and RBBB. Now, we will solve RAVA. So it is just the parallel 75 times 15k divided by 75 plus 15k. So we already solved this one a while ago. That is equal to in total tayo. 5,000. That is 5,000 ohms. RBB is 15k times 15k divided by 15k plus 15k. So that is equal to 7,500 ohms. So total resistance will be RAVA plus RBBB equal to 5,000 plus 7,500. So that is equal to 12,500 ohms. From here, urahan mo alain ni total resistance mabalin mo masolve ni R ni EA can EB tayo voltage drop using VDT. Urahan mo alain ni total resistance So we will just use voltage divider theorem. So EA is equal to total voltage maalam mausar mo gayam multiplied by RA BA divided by total resistance. So mabalin mo met ala ni total current na ditoy. Then usarem ni VA is equal to IT RAVA or VB is equal to IT RVBB. And also you can use CDI VDT. So 120 times RAVA, which is 5,000 divided by 12,500. So 120 you have 48 volts reading in your voltmeter A. Voltmeter B, EB is VT times RBBB divided by RT. So 120 times 7,500 divided by 12,500. So you have 72 volts. Okay.